Now, if you consider yourself to be among the many who get that incredibly uncomfortable feeling moving up their spine when they hear the words plant and consciousness uttered in the same sentence, rest assured, you can sleep well in the knowledge that you share your inclinations with the vast majority of the world's botanists and biologists. Ever since the hype and subsequent backlash of 1973's bestseller, The Secret Life of Plants, many academics have been acutely sensitive to the merest hinting of an association between plant and animal experience. Stories that claim plants can respond positively or negatively to various styles of music, to verbal or even telepathic praise and insult. And even tales which go so far as to claim that plants can identify culprits from a lineup after being witness to a murder. Stories which, understandably, can get under the skin of your average scientist. Though most botanists tend to shy away from accepting an explicit intelligence in plant life, such intelligence is often hard to ignore, even for the average gardener. Flowers quite clearly arc towards sunlight, as roots will seek out moisture, and many plants will even release insecticides when attacked. And it's this intelligence that we now investigate, so as to further our inquiry into the boundaries of consciousness. So join me as I attempt to unpick the infinities of what is. From ancient Greek scholar Theophrastus, the father of botany, to Charles Darwin, inquisitive and insightful minds have long sought to uncover the riddle that is this unconscious life. Indeed, Darwin himself dedicated the entire second half of his life to investigating plant life, writing as many as 6 books on the topic. His root-brain hypothesis was featured in 1880's The Power of Movement in Plants, his second-to-last book, co-authored with son Francis Darwin. In the final pages, the Darwins presented their case for an almost animal-like intelligence, inhibiting all plant life, writing, "We believe that there is no structure in plants more wonderful, as far as its functions are concerned, than the tip of the radicle. If the tip be lightly pressed or burnt or cut, it transmits an influence to the upper adjoining part, causing it to bend away from the affected side. It is hardly an exaggeration to say that the tip of the radicle, thus endowed with sensitivity and having the power of directing the movements of the adjoining parts, acts like the brain of one of the lower animals, the brain being seated within the interior end of the body, receiving impressions from the sense organs and directing the several movements." Perhaps, not surprisingly, in today's climate of environmental struggle, scientists have begun to take a closer look at Darwin's more controversial ideas, reinventing the field of phytobiology. A field which may have remained within our peripherals for far too long. But that said, it is perfectly common for us to consider plant life as little more than mere props on the stage and theatre of life. Even as children, we would name entire alphabets worth of animals, barely any we had seen with our own eyes, and yet few could have named more than a single plant from their own backyard. This trait of our psychology is commonly referred to as plant blindness, and due to the highly publicised pseudoscience distractions of the early 70s, such plant blindness has only become further ingrained within our academic circles, leaving as a result some otherwise promising studies out in the cold. Though a great deal of compelling research has nevertheless been conducted, often revealing surprising parallels between plant and animal biology. Similarities found not only in behaviour but also in the way that information itself is transferred on the cellular level. Although plants don't host neuronal cells, they do, like the sponges, contain those same chemicals that serve as neurotransmitters in us. Chemicals such as serotonin, dopamine, calcium and glutamate all work together just as they do within our bodies, though much of the plant's molecular mechanics are still far from being understood. The field has come a long way since the clearly defined botany of Darwin's time, now growing to include many extending tendrils of speciality, such as ecology, plant physiology, plant molecular biology, plant cellular biology, and even plant electrophysiology, all of which offer new perspectives on these, our often bypassed cousins. And in the light of the imposing AI era, as our fascination with consciousness has only continued to heighten, we have begun to witness the emergence of some slightly more controversial fields of study. Fledgling branches of investigation, such as plant cognitive ecology and the more dubiously named plant neurobiology. But like all pioneering fields, these are those who tend to find themselves on the outer fringes, each in their way coming to terms with the realization that support for their research will, for the foreseeable future, be of vastly mixed opinions. In a 2018 interview, former evolutionary ecologist turned plant cognitive ecologist Dr. Monica Gagliano recalled an occasion when one such anonymous academic peer review opened their statements with the comment, "It's very unlikely that plants are aware or conscious, so this entire project is meaningless." And considering that Dr. Gagliano's research, of which we shall discuss shortly, had never declared the existence of any such plant consciousness, it's clear how defensive and pre-decided the academic community can more often be. Dr. Gagliano has been noted as taking equal offence to any such pseudoscience claims, and like many, she is very cautious of those who casually use language such as neurobiology when it comes to systems that don't have traditional nervous systems. As such, Gagliano has been the one responsible for the term plant cognitive ecology, as she considers this to be the most scientifically accurate title for the phenomenon she's witnessing in the field, i.e. cognitive ecology, the study of cognitive learning within both social and natural contexts, only in this case as it's applied to plant life. Her growing list of experiments has shown us that the plants not only have the ability to react to their environment, but can also sense, adapt, learn and retain information. The most common difficulty when studying plant behaviour is simply their much slower timescale. To combat this first hurdle, Gagliano, like Darwin, turned to using mimosa plants, which, like the Venus flytrap, can react to stimuli at speeds more in line with our own. This is witnessed when the plant is either brushed or knocked, causing the leaves to close up like the wings of a butterfly, revealing their thorny spines and so defending them from any potential predators. In one experiment, Gagliano would routinely drop her pot-planted mimosa from a height of 15 centimetres, whereby its impact with the ground would cause the leaves to instinctively snap shut. The lesson, however, was only learnt by the plant when they began to realise that such a drop and sudden impact had not been a threat to either its foliage or survival. And because closing your leaves is such an energy-expensive act, which then further denies an ability to absorb sunlight, these mimosa plants needed to learn their lesson quickly. Being dropped is simply not a drama worth closing your leaves over. And so it appeared that after an average of 3 such falls, the plants would learn this lesson. Somehow the plant had determined that a drop was more or less non-threatening, differentiating this experience from other forms of interaction, and so would save its leaves from closing. What was interesting was that plants could retain this newly learnt information over long periods. Even up to a month later, plants could still recognise the drop and react to it as non-threatening. The study also showed that individuals raised in low-light environments would learn quicker, where failing to learn would have a greater impact on their chance for survival. These same plants were also less likely to forget the lesson, and so would remain vigilant once moved to a more bountiful light source, whereas the slower, plump, sun-rich plants would change their behaviour when moved to a harsher environment, each reacting to their own best plan for survival, considering not only their present situation but also their past and thus their potential future. In other experiments, pea vines were trained to recognise an association between an inherently meaningless form of stimulus and food, in much the same way that a dog can be conditioned to associate the sound of an inherently meaningless bell with their dinner time. The pea vine was trained to recognise the presence of wind provided by an electrical fan as the precursor to the appearance of light. Whereas in 100% of the control cases where pea vines would grow solely in the direction from where they had last received light, the trained vines would instead move away from the last known origin of light in preference for the direction of the fan, suggesting a level of awareness that can shape intelligent action. The issue we face when using words like intelligent is that we as humans already have a very personal experience of this thing we call intelligence, and as such tend to muddy the use of the word by associating our interpretation with its more literal definition, that being simply an ability to acquire and apply knowledge and skills. And although this definition has only historically referred to abilities born of a nervous system, its relevance in this scenario seems very hard to disregard, because though the plants may not think as such, they do acquire sensory information, learn and react, and even going one step further to communicate. But where, if not in a brain, is this information stored? And what even is this information? And how does this information manifest itself as an intelligent action? And inevitably, what does this say about our own intelligence and therefore its relationship to what we experience as consciousness? The answer, sadly, is that we have very little idea. We do know that plants don't have neurons or any traditional nervous system to speak of, but it should also be noted that as the nervous system is simply a congregation of specialised electrochemical impulses, so too is the system used by the plants in their reaction to senses. Quote, "We shouldn't focus so much on saying it's the brain doing things, it's the nervous system doing things, but actually look at the functional aspect of the story." End quote. As Gagliano points out, all life seems to have this intelligent power, a power that, regardless of the system, always seems fundamentally interlocked with electricity. In our cells, the information acquired by the senses is activated by the neurotransmitter glutamate, which then initiates a flow of calcium ions, allowing one cell to communicate with the next. Equally, when a plant is touched, cut, or damaged, studies have shown that it is this same glutamate that encourages these same calcium ions to flow through the plant's vascular system, alerting the plant to a possible danger. And not only can they feel in this way, but they've been recognised as commanding up to 20 senses, including a sensibility towards light, moisture, wind, gravity, electromagnetic fields, and can even pick up a balance of chemical substances in the soil. But the one sense that hits closest to home is that they actually seem to be able to hear. The field of plant bioacoustics is a long-standing area of investigation, examining the various ways in which plants interact with and even produce sound. Using a specialised laser-based microphone, We can now measure multiple aspects of plant health, from drought stress to pest infestations. The question is, how do the plants themselves use this vibrational information? One 2014 study conducted by Heidi Appel and Rex Cocroft at the University of Missouri demonstrated that certain plants will release substantial amounts of defensive chemicals when audio recordings of munching caterpillars were played. Similarly, Gagliano's team showed how root systems grow towards the recorded sounds of flowing water. We often assume that plants are mere islands in the dark, but they are, in fact, in constant communication with one another. Gagliano's team has even captured recordings of tiny, repeated clicking sounds emanating from the roots that she suggests are being used in plant communication. This supported by the fact that chili plants, when sitting alongside fennel, are no less aware of one another's presence even when cut off from the other's chemical and scent signals. One famously aggressive quality of the fennel is that it chemically suppresses the growth of the plants which surround it. And so in a pre-defensive act, these chili, upon hearing the arrival of their unruly neighbour, accelerate their growth. Only time will tell how plants are utilising this acoustic energy, but with that said, plants have long been known to communicate in a great variety of ways, colour and scent being the most obvious to our senses. But for the plants themselves, their more elaborate interactions tend to occur underground. Plants communicating with one another through the mycorrhizal networks of fungi have been shown to warn their surrounding kin of potential dangers, even recognising their own offspring, and using the underground network to send carbon, nutrients and water in times of need. This so-called wood wide web acts as a shared information highway, passing along the forest's messages of wealth, danger, opportunity and starvation, connecting the forest in an all-encompassing symbiotic relationship. And in this sense, the mycorrhizal network, boasting more network connections than the count of neural pathways found in the human brain, bears many similarities to that weaver of magic, the nervous system. But communicative intelligence isn't reserved solely for the plants, as these fungi can themselves exhibit numerous signs of intelligence. The mycelium network of mushrooms are the world's largest living organisms, some covering up to 2,300 acres and weighing as much as 35,000 tons. A colossal mass of membranes capable of investigating, learning and adapting as it seeks sustenance, evades predators, and even vaccinates itself against pathogens found in the undergrowth. And just like the nervous system, does it too transmit its information via electricity, surging electrolytes along its trillions of branches. But do any such reflections of communicative intelligence play any relevance in our hunt for the borders of consciousness? Are we not just setting ourselves up to again confuse our definition of consciousness with our definition of intelligence? Interestingly, the perspective of intelligence described in the forest fungi network does draw our attention to a very curious attribute, in that intelligence does not always need to be contained to a single living, thinking individual. The unconstrained intelligence of nature appears all around us, present in the collective intelligence of the interwoven forest, just as much as in the unified movement of fish and birds who move as one to evade a predator. There are higher forms of intelligence at work in the unspoken coordination of ant colonies, and even in the simplest congregation of cells. Simple slime molds have been shown to possess remarkable problem-solving skills, navigating mazes and even determining optimal navigation routes on city maps. What's more, it too can both learn and pass on information. Once a congregation of slime mold cells have learnt that a food source sits beyond a deterrent barrier like a salt bridge, It can then pass on this knowledge to other segments who would have otherwise avoided the salt bridge entirely. And then, of course, the waters muddy even further with the intelligence present in the ever-growing complexities of computing and AI. So it seems evident that intelligence can persist beyond the bounds of a unique conscious driver, and for that matter beyond life itself, found inherently present within the languages of chemistry and physics. So perhaps it is this same emergent intelligence that we observe in plants. But if this is to be the case, doesn't that mean that the matter bears next to no relevance to our greater inquiry into the bounds of consciousness at all? Here we must tread lightly, and again be very wary of using words such as intelligence, life, or consciousness too boldly, as the accuracy of their usage depends deeply on the particulars that we wish to attach to their definition. Because though the dreaded C word is more likely to send botanists running, experts like Gagliano are more than happy to draw our attention to the fact that we still currently have no scientific definition for what consciousness is, and that though plants may not think the way we do, they do host many behavioural traits which, though currently unaccounted for, if found present in any animal, would be attributed to the presence of a nervous system. So here is the fun part. Looking only to the philosophical for reference, we are now being forced to draw our own lines in the sand, somewhere just beyond the shorelines of our understanding. So can we recognise a form of consciousness existing within plants, fungi, or any other such complex system? Here I think we can easily trip ourselves up by emotionally placing the anthropomorphic cart before the academically respectable horse. Instead of going down the rabbit hole in pursuit of this tantalising idea that the above examples of intelligence are evidence for some form of animal-like consciousness existing in plants, we should instead consider it from the other direction, from the perspective that our consciousness could similarly be considered a reflection of how the plants interpret their world. Shifting one's perspective like this allows us not to be distracted by such fragile fancies, and to instead focus our attention on the functional attributes, as Gagliano suggests. But the reason why many will avoid this approach is because if we were to have our inner world mirror the more automated response of the plant, be it at a much higher level of complexity, then this would shed a very particular light on the nature of our consciousness, in that one of our own most enduring characteristics, that of free will, would turn out to be little more than an illusion. Indeed, this is the very argument given by a reductive materialist. Perhaps Radiohead said it best: just because you feel it doesn't mean it's there. But now that we're on this side of the fence, we must again remind ourselves to be cautious with our use of language, because by suggesting that free will might be an illusion, we do not necessarily mean to say that it doesn't exist. Simply that, like all illusions, its nature is other than what we perceive it to be, and that whatever this nature is, it must share some slight lineage with the intelligence we attribute to plants and other such systems. Of course, defining what it is may not be so easy, and so may take more than just a few chapters to unfold satisfactorily. Still, the simpler quandary as to why such illusions would persist in the first place should be fairly easily resolved. As with any sensorial illusion, these only tend to persist so long as they serve to benefit our survival. The light hitting our retina is received upside down. The illusion that we are seeing the world right way up persists to aid our survival. This is an idea we've touched on several times now, that this mind's eye experience of free will is as real as any experiential phenomenon can be, but still, there is no universal requirement for the phenomenon that we name to host any absolute identity. The physical and the experiential are, I would say, examples of interrelated phenomena, both built upon one another's influence. But there is still much that is obscured by the misinterpretations of this first-person perspective. More likely than not, the trajectory of our current understanding will continue to yield contradictory truths until we reveal a necessary perspectival shift. Because just as it is with the divide between classical and quantum mechanics, an understanding of actions occurring in each domain does not guarantee us a complete picture. The problem again being that we can never know how much of the desert we aren't being made privileged to. But why do I again draw our attention to the potentially illusory attributes of our consciousness? Returning to the topic at hand, this experience of free will appears to us as the crucial difference between our experience of awareness and that of the plant kingdoms. An awareness that justifies its choices via a self-referential understanding of its own existence. But therefore we must acknowledge that we can never know what illusions present themselves in the process of being a plant, what illusions of perception allow for its navigation of the world. And even if plants were to have what we would consider a totally vacuous experience, and so in that sense lack the self-referential understanding that we attribute to a force of will, there is still another thought that might be worth considering. In the idea that their perspective could possibly be considered legitimately less flawed than our own, a less cluttered experience of reality, one that would work in stark contrast to the fantastical, multicoloured sensory illusions of the hyperactive ape brain. Those which are eternally misled, convinced by the biases of their senses and the experiential interpretations of local vibrations. In other words, we just need to remain vigilant in reminding ourselves that we have a very human-centric experience of reality. A perspective that is but a mere infant in this universe. To say that modern animal consciousness is the sole particular system needed to interpret reality would be to say that any expression of awareness prior to the arrival of complex animals dealt entirely in illusion. But if that's the case, how could total illusion ever lead to total cognizance? Realistically, we need to consider the ultimate nature of reality as something far deeper, denser, and infinitely more layered than anything that living consciousness has yet to uncover. Consciousness, as we, the finite experiencer, knows it, merely skims along the surface of the extended reality. Because the stake in the sand, the idea that we continually circle back to, is that our consciousness is only one in an infinite number of possible perspectives. The point is that the plants, however unique, equally translate this shared reality, even if they do so along an axis that lies beyond our comprehension. They are different, incontrovertibly so, but they, like the vast array of animal life, merely translate or become or unfold a limited slice of this deeper reality. So it's not that the plants do or don't experience as we do, it's that nothing and no one experiences as you do. To quote the legendary pythons, you are all individuals. So now let us finally offer something bold and state our first law of consciousness, which is that any perspective must be uniquely finite, as no one perspective can ever embody perfect equality with another. And yet, As these unique perspectives continue to mount, the one contrary truth also remains clear: that each finite totality is always a part of the same opera omnia, a collective that abides in unbroken continuity, both being and becoming this shared infinity. As stated by American mycologist Paul Stamets, the fact that we lack the language skills to communicate with nature does not impugn the concept that nature is intelligent. It speaks to our inadequacy for communication. End quote. No living thing needs to be the same as us for its interpretation of reality to be considered accurate or even relevant in our broader conversation concerning consciousness. There is experience at work, however far removed from what we personally refer to as consciousness. The great slow lesson of the human race has always been to expand our thinking, to gradually accept perspectives that differ from our own. And so, if we do choose to use words such as consciousness to define this experience, then we must try to identify it in all its forms. Then, and only then, may we have any hope of obtaining a more fundamental understanding